This video is going to focus on a new concept for you in Math 20-2, and it's using a quadratic formula. Now, to use the quadratic formula, we have to be talking about quadratics in standard or general form, as it's shown up here. So we've talked about this earlier too, where it's ax squared plus bx plus c. The quadratic formula will work on quadratics that are in that form. So if it's given to that form, we can use it, or we can use some algebra to get it into the form we need. Now, the quadratic formula is actually just this big equation here. Now, this equation will always be given to you on a formula sheet or on the board for any kind of assessment or any kind of activity. But it's important to note that the quadratic formula is just another way to solve a quadratic. So in other words, it's just another way to find your x-intercepts, your solutions, your roots, your zeros, whatever you want to call them. Now, we use it when either A, you don't want to factor, or B, the quadratic that you're trying to find algebraically through factoring is not factorable. So there's nothing that you can do to factor it. This is where the quadratic formula comes into play. So we're going to look at an example or two here on how to use it. And it's pretty straightforward if you can organize your work. So I'm going to look at this quadratic over here that is 2x squared plus 11x minus 1. It is in standard form. And that means that this is A, this is B, and this value is C. So in other words, A is 2, B is 11, and C is -1. So all of these values actually take the sign with it. If it's positive, it's a positive value. If it's negative, like the C is here, -1, it keeps a negative value with it. So the quadratic formula above here, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. This is where we have to plug these ABC values in. So we're going to start. We're going to say x equals, and we're saying x equals because it will tell us our x-intercepts. It says -b. So if I look, my b is 11, so I'm going to say -11. I'm substituting in with brackets. Plus or minus. Now comes the radical sign. It says b squared, so that's 11 squared minus 4 times a, which was 2, times c, which was -1. Now this radical goes all the way across. And now this whole thing is the numerator, and it's going to be divided by 2 times a, which is 2 times 2. So I substituted in all the values I need for the quadratic formula. Now it's just a matter of using some algebra to figure this stuff out, just some normal skills calculations. So the first part, -11, well, that just turns out to be -11, plus or minus the square root of 11 squared is 121. And now we look at these three multiplications here. We're saying -4 times 2, that's -8, times a -1, well, that's +8. All over 2 times 2, which is 4. So we did the calculations simply. Now it's just a matter of cleaning up our information. We got -11 plus or minus the square root of 129 all over 4. And now we should be seeing if we could, from our radical unit, simplify the 129. In this case, it doesn't simplify down to any mixed radical. So this means we actually have two roots. There's one x-intercept where x equals -11 minus the square root of 129 over 4. And then there's also one where x equals -11 plus the square root of 129 all over 4. So what this is actually saying, when we look back in our equation, here's a sign that you may or may not have come across before. Plus or minus, it's just a way to write a formula more concise. We're saying we have to subtract it on one side and add it on the other. So we have two x-intercepts. It's crossing exactly at this point, which is an irrational number. We couldn't get it through factoring. And it's crossing at this point. So we could look at those values as decimals if we wished. And if you wanted to put them in your calculator to determine their decimal approximations, you'd realize that this guy is actually x equals approximately -5.59, and this is x equals approximately 0.09. So if we were to consider this quadratic parabola way back at the beginning, we could see that there is a positive leading coefficient right here. So we know that this quadratic is opening up, and it has x-intercepts at approximately these places. So if I needed to sketch it, I could say, well, one x-intercept is somewhere over here at negative 5.59. We have another x-intercept somewhere around here, which is 0.09. Looking at the equation, you also know the c value is negative 1, so that is crossing somewhere, let's say down here at negative 1. So my quadratic is actually something to this effect. Now, all this question with the quadratic is asking you to do is find your x-intercepts. These are the values that you want. These are the exact values of the x-intercepts. We're just using all of this information right here to show you what it actually means in context that you could probably understand. So we're going to take a look at another example here just to get some more practice with the quadratic equation. So here is our next equation we're going to look at, negative 3x squared minus 4x plus 5 equals 0. Now, we could try to solve this through factoring. If you don't want to factor, we could always use this quadratic formula, or if the quadratic itself is not factorable, we start to use this quadratic formula. So the first thing I'd recommend is going through and identifying what your variables are. So from here, I'm getting a is negative 3, and b is negative 4, and c is a positive 5. And we're just getting it right from these coefficients and the constant. So these are the values now I have to put into the quadratic formula, which is right here and which I said will always be provided for you. So we start with x equals, it says negative b, so I put a negative sign, and then I look b, well that's negative 4, so this is actually a negative 4, and that's important to have those brackets. Plus or minus, now we look at the b, again that's a negative 4 in brackets squared, and you have to remember that those brackets are critical, especially when we have a power of 2. Then we put in the other variables, minus 4 times a, which is negative 3, and then times c, which is a positive 5. So there's my numerator, the top of this. The denominator, or the bottom, is just 2 times a, which is 2 times negative 3. So we substitute it into the equation. Now it's a matter of just using our calculations to get this down to some numbers. So the first part, I have negative 4. That turns out to be a positive 4. Plus or minus, now I have negative 4 squared, which is negative 4 times negative 4. That's a positive 16. Now I look at these other multiplications. I have negative 4 times a negative 3. Well, that's a positive 12. Times a 5, that's positive 60. And the denominator now, 2 times negative 3, well, that's just negative 6. Now we clean up what's in that radical sign. So we have 4 plus or minus the square root of 76 all over negative 6. Now we look at that radicand and we try to decide if we can actually simplify that radicand of the radical anymore. So we have 4 plus or minus, from our radicals unit, we could break this up into perfect squares. That's actually 4 times 19, because the square root of 4 is a perfect square, all over negative 6. So if we keep going, we get 4 plus or minus. Now we take the square root of 4, and that's 2. And what I'm left with is the root of 19 all over negative 6. So we're almost there. This is getting really close. If you're here, you're understanding the quadratic formula. Now we're combining two units and trying to simplify these equations. We can look at all of these values here and realize all of those are divisible by 2. So I could take a 2 out of the top and say, well, I got 2 plus or minus the square root of 19. All over, and on the bottom, I could say, well, that's 2 times negative 3 So we're simplifying this a bit. We could see 2 divided by 2 comes out to be a 1. So my quadratic equation or formula came up with these roots, 2 plus or minus the square root of 19 over negative 3, which in our last example, we realized these are actually showing me two roots. One where x is 2 minus the root of 19 over negative 3, and one where x is 2 plus the root of 19 all over negative 3. So here are two places where this quadratic is crossing the x-axis. If you can get to this stage right here, if this was on a rubric, you'd be at a level 4. You understand the quadratic formula extremely well. If you can get to a stage right here, and simplifying the radical even to here, if these are where you kind of go and then the simplifying the radical breaks you down, you're doing fantastic still with the quadratic formula. This would be considered a level 3 on a rubric. You're understanding the formula. You're just having a hard time simplifying it down using our skills on radicals. So there's one more example on the quadratic formula.